Hi everyone, this is Miss Fisher, and I'm going to go over the staircase problem. I had done a demo in the school stairwell, but I know it was a bit hard to hear. Because of the technical glitches, I wanted to do a video just to make sure you understood the problem and help you get started. The original question is, suppose you had a staircase and with n steps, for example, 100 steps, and you are allowed to skip steps, but you're not allowed to skip more than one at a time. How many different ways are there to climb the staircase with n steps? And go ahead and list all the possible ways to climb that staircase with n steps. So for our, just as our demo, we're going to show how many ways are there to climb a staircase with 5 steps. And again, if you are allowed to skip steps, but not more than one at a time, and to list all the possible ways. And to denote the pathways, we're going to use 0 to represent a step that we actually stepped on, and a 1 to represent a step that we skipped. So if you only had one step, in other words, your staircase had one step, that would be really simple. And there would only be one way to climb that staircase. Okay, you would have to just step on that step, right? If you don't step on it, then you're not considered having climbed that staircase. So you can represent it with the 0. Okay, and we're going to represent, again, the pathway with a binary sequence. So suppose there were 2 steps. Well, then you could step on both of them, and we can represent that as 0, 0. Or you can skip the first one and then step on the second one, and then you can represent that as 1, 0. But suppose that we decided to try 0, 1, and we stepped on the first one and we skipped the second one. Well, if you look at this staircase, you didn't actually climb 2 steps. You only climbed 1 step. So this would not work. Okay, so you do have to step on that last step, okay, the nth step, in order to have been considered a valid pathway for n steps. Okay, so then if we take a look at 3 steps, you can step on each one, 0, 0, 0. You can skip the first one, or you can skip the second one, but you can't skip the third one. And we are going to start looking for patterns to see how many total pathways. So far we have 1 step gives us 1 pathway, 2 steps gives us 2 pathways, 3 steps gives us 3 step pathways. Let's see what 4 steps give us. Is it 4 or more? So if we take a look at the possible pathways, you can step on every one of them. 0, 0, 0, 0. You can skip the first, you can skip the second, you can skip the third. But take a look at this one. You can actually skip the first and the third. So now there are 5 valid pathways, okay? And if you take a look at 5 steps, then there are actually 8 pathways. So now if you start looking at this pattern, it looks very familiar, the sequence of numbers. We've got 1, 2, 3, 5, 8, and then you may hypothesize that 6 steps, number of steps would be 6, would actually give you 13 pathways. So it is the Fibonacci sequence. And in class, we're going to talk about why we do have that sequence describing the number of pathways. But I do want to help you with the actual lab itself. So we're going to take a look at Replit 5.7. You're going to be asked to implement the staircase class, and 2 of the methods are called getNumPaths, which returns the number of pathways, and you can compute the Fibonacci sequence with 1 num step will give you 1 pathway, and 2 num steps will give you 2 pathways, and so forth, and you can just compute from there. And then let's talk about printAllPaths. It's going to print all the possible valid pathways, okay? We're going to take advantage of the binary representations of numbers and also use bitwise operators. So in print all paths, we are going to iterate from the number 0 to basically to the num steps minus 1. However, we're only going to check the even numbers, okay? Because we need to step on that last step. So if we go back to these representations, notice for all of these bit sequences, the last number is always going to be 0. So in this case, this number is equal to the decimal number 0. This number is equal to the number 8. This one is 4. This one is 2. This one is 2 plus 4, which is 6. So a valid pathway will never have a 1 at the end of its binary sequence. Therefore, we don't need to check odd numbers. We're only going to check the even numbers. And if you think about 4 steps, the biggest number that you can make with 4 bits is 1111, which is 15. So the number will always be less than 2 to the num steps power, 2 to the 4th in this case. Okay? So we're going to use a for loop. And start from 0 and go to I less than math.pow, 2 num steps, 2 to the num steps power, only checking even integers. So we will increment I by 2 each time, beginning with 0. Okay? So, and again, we're only going to check the even integers. So even though it ranges from here to here, we're just going to check the even integers. Now, once we check the even integers, we've got to decide not all the even integers will be valid, right? For example, here's an example of an invalid, and it's invalid when you've got 2 1s in a row. You can't skip more than 1 step in a row, okay? So let's take a look and see what happens if we use a bitwise operator and shift 1 space to the left, 1 place value to the left. If it's a valid pathway, for example, suppose we've got the number 01010100, okay? So this is a valid pathway, and if we do a bitwise shift to the left, bitwise left shift 1 position, everything will be shifted, and then you've got this extra 0 here. So if you perform bitwise AND to each of these bit values, then you will get all zeros, okay? But suppose you have an invalid pathway, that means that we're only checking even integers, so the last digit is always 0, but you will have skipped more than 1 in a row. So here's 2 steps that you skipped, okay, in a row. This is invalid. If you make a bitwise left shift 1 place to the left, notice that because there's 2 in a row, if you shift 1 place, then when you AND this particular place value, this column, you're going to get a 1. So therefore, the output of I and I left shift 1 will not equal 0. You're going to have at least 1 true, okay, 1, 1. Okay, and so when you evaluate this, this will not equal 0. So when you actually implement this print all pathways, what you're going to do is this. You're going to you're going to loop again from int I get 0 to I less than math dot pow to num steps, okay? And remember, num steps is going to be the instance variable here, okay? And you're going to fill out the rest of this code. So once you have this, and you're going to check if, oops, I forgot to update here. Sorry about that. And we're only checking even integers, so it's going to be I plus gets 2. Okay, so you're going to check 0, and then 2, which if you write it as a binary sequence, it would be 0, 0, 0, 1, 0, right? If you had 5 steps, okay? So if if you shift I over 1 place to the left, Okay, if that is going to be equal to 0, then you're going to go ahead and print that pathway. And you are going to need to implement des to binary method, because the pathway, for example, if you had the number 4, which is 1, 0, 0, okay, suppose you had 5 steps. You actually want to print 0, 0, 1, 0, 0. Okay, the pathways should have however many digits, num steps, number of bits, right? So you're going to need to concatenate 2 zeros here. Suppose you just had 0, 1, 0. Okay, suppose you actually had 1, 0, or the number 2, okay, which could be a possible pathway. You would, again, if there are 5 steps, you would want to print 0, 0, 0, 1, 0. So that is what you're going to do for this method here. Des to binary, if you scroll down, this is a helper method, and you're going to return the binary representation. So you've got the decimal numbers between 0 and 2 to the num steps, right? I is less than math.pow, so this is 2 to the num steps. As long as it's less than that, and you're incrementing by 2, you're going to check all these decimal numbers, but then if it's valid, if you check this condition and it's true and it's valid, you want to print that binary representation, okay? And so all of those pathways should have, if there's num steps, there should be num steps bits, okay, or binary digits here. Okay, so this is basically if pathway is valid. This is basically it for this part of the code, all right? But you do have to complete this and then this, which is basically the Fibonacci sequence, but the 2 seed numbers will be 1 and 2, and then so forth, okay? And then, of course, the rest of the code. All right, I hope this is helpful, and I will see you in class. All right, bye, everyone.